A 112 grams channel can pass controlled impedance testing. The impedance result may look correct, but the channel can still lose performance through the via transition when the signal leaves a plated through hole on an internal layer. The unused section of the via barrel remains below the signal layer. That unused section is the via stub. At high frequencies, the unused stub is not just extra copper. It behaves like a resonant branch connected to the signal path. It can create reflections and limit the usable bandwidth of the via transition. The effect may appear as degraded return loss. It may also increase insertion loss. Channel bandwidth and I margin can both be reduced. Backdrilling uses controlled depth drilling after fabrication. It removes most of the unused plated via barrel. This reduces the electrical length of the stub. Backdrilling does not normally remove the entire unused barrel. A controlled remaining stub is usually left. It protects the signal layer and accounts for drilling tolerance. The strategy depends on where the signal enters the via. It also depends on where the signal exits. Different layer transitions require different backdrill directions and depths. Backdrill depth must be controlled against the target layer. If the drill stops too early, the remaining stub may still be too long. If it drills too deep, it can damage the signal layer. The manufacturing depth tolerance is part of the electrical design. Backdrilling is only one part of the via design. Pad size, anti-pad geometry, and differential spacing also matter. Return vias and reference plane continuity complete the transition. TDR can help identify impedance discontinuities in the manufactured channel. S-parameter testing can evaluate insertion and return loss. Microsection inspection can confirm the actual drilled structure. The actual remaining stub should be verified, not assumed. Review where the signal enters and exits the via. Define the acceptable remaining stub length. Check backdrill depth, drill tolerance, and via geometry together. Then validate the manufactured structure and channel response. If your project includes 112 grams or 224 grams SERDs, backplanes, switches, optical modules, or AI server boards, UltroNiu can review the Stackup and Backdrill requirements before prototype release.